Curiosity and imagination have long driven researchers worldwide to explore a millennia-old question: is it possible to bring extinct species back to life? This question lies at the heart of scientific exploration, pushing research to new frontiers in genetic engineering. Subscribe to our channel and click the bell to stay updated. Today, we'll discuss the de-extinction of the woolly mammoth, shedding new light on the possibilities offered by the latest scientific discoveries. The symbolic elephant, revered for its wisdom and strength, becomes an unexpected protagonist in this scientific narrative. Its skin cells can be transformed into stem cells, an extraordinary achievement that opens new perspectives in genetic engineering. This milestone, announced by an American company, represents a significant step in the research aimed at the de-extinction of species. But why should we go to such lengths to bring the woolly mammoth back to life? In fact, this giant would play a crucial role in the tundra ecosystem, helping to maintain the permafrost. Mammoths, by constantly trampling on moss, shrubs, and trees, shaped the landscape and promoted the growth of smaller plants and grasses that absorb less sunlight than trees, thus helping to keep the ground cooler and preserve the permafrost. This layer of Earth has accumulated enormous amounts of carbon dioxide over millennia and must remain intact to prevent the release of these emissions into the atmosphere. The De-Extinction project has been in development for over 20 years, and many other animals, such as bison, musk oxen, yaks, and reindeer, have already been reintroduced to the tundra. It is hoped that within the next decade, the project can bring the woolly mammoth back to life. The first woolly mammoth, discovered in the Arctic permafrost, dates back over 30,000 years, but its tissues are not sufficiently intact to allow a complete reading of the genome. However, elephant DNA is 99.9% identical to that of mammoths, opening up the possibility of creating a new hybrid by combining mammoth genes with those of the Asian elephant. This hybrid mammoth would be able to withstand extreme temperatures down to 40 degrees Celsius. A fundamental aspect of this process is the Yamanaka procedure, named after Japanese scientist Shinya Yamanaka. This innovative method allows the transformation of differentiated adult cells into induced pluripotent stem cells, IPS, opening new horizons for research and therapy. Yamanaka factors play a crucial role in reprogramming elephant cells, allowing them to revert to a state similar to that of an embryo. The potential of reprogrammed stem cells is immense, from the production of oocytes and sperm to the creation of synthetic embryos. These discoveries pave the way for a vast array of possibilities in the field of reproductive biology. The idea of creating an artificial womb represents an ethical and sustainable alternative to the natural reproduction of endangered animals, offering new opportunities for increasingly precise research and experimentation. The journey toward de-extinction has just begun, paving the way for a future of unprecedented scientific discoveries. Through the perseverance and passion of researchers, we are guided toward new horizons of knowledge and possibility, driven by the vision of a world where extinct species can be brought back to life and the biodiversity of our planet can be preserved. De-extinction, considered by some to be a utopia, is in fact a field where expert researchers invest time and resources. Although there are criticisms of the validity and utility of these efforts, de-extinction science has already made remarkable progress thanks to gene cloning and DNA extraction. It is expected that in the future, this technology could also be applied to other fields, such as medicine and agriculture. Cloning, for example, could revolutionize agriculture by allowing the selective production of animals with optimal characteristics and contributing to biodiversity conservation through the reintroduction of endangered or extinct animal species, rebuilding entire ecosystems. Ultimately, de-extinction could offer significant opportunities for nature conservation and the protection of endangered species. We conclude this presentation with gratitude to those who have made this epic endeavor possible. We look to the future with optimism. Scientific research will continue to illuminate our path toward new frontiers of knowledge and discovery, offering hope and prospects for a better world for generations to come. Thank you for joining us on this journey through the wonders of genetic engineering. We look forward to seeing you on our next exploration.